Now the question number 21. A conducting rod of length L rotates with angular speed omega in a uniform magnetic field of induction B, which is perpendicular to the motion. The induced EMF developed between the ends of the rod is how much? So here first of all, in this question, here there is an uniform rod of length L which is rotates with angular speed omega in a uniform magnetic field. It is uniform magnetic field. It is rotating with angular speed, and find which is perpendicular to motion. The induced EMF developed between the ends of the rod is how much? So first of all, from here to here, this is I will take as L by 2. Now first of all, it is moving means first of all we will calculate linear speed. That means V is equal to R omega. So that means V is equal to R means what is that here? L by 2. This is length, L by 2 omega. So that means V is equal to L omega by 2. This is the linear speed. But which one we want to calculate here? Induced EMF developed between the ends of the rod. That means these two ends, how much amount of induced EMF? E is equal to BLV. So that means B into L. V means what is that here? L omega by 2 is equal to BL square omega by 2. So which option is correct here? Bombay. B is the correct option. Now the question number 22. A moving coin galvanometer of resistance 100 ohms shows full scale deflection when current of microamperes passes through it. If it is intended to show full scale deflection when a current of 1 milliampere passes through it, the value of shunt resistance in ohms to be connected to the galvanometer is how much? That means we have to calculate the shunt resistance. That means here moving coil galvanometer of resistance 100 ohms shows full deflection when a current of, this is 100, that is 100 microamperes of current, here 100 microamperes. So first of all, so the resistance of galvanometer G is equal to 100 ohms, and the current which passes through the galvanometer Ig is equal to 100 microamperes. That is nothing but 100 into 10 to the power of minus 6 amperes. When the current passes through 1 milliampere, then how much amount of shunt is needed? So that means the current which is present here, 1 milliampere, is nothing but 1 into 10 to the power of minus 3 amperes. But which one we want to calculate? Shunt resistance. So that means here shunt resistance S is equal to current through the galvanometer and galvanometer resistance, and current minus current through the galvanometer. So here current through the galvanometer, that is 100 into 10 to the power of minus 6 into galvanometer resistance, that is 100, divided by 1 into 10 to the power of minus 3 minus 100 into 10 to the power of minus 6. So here 10 to the power of 4 into 10 to the power of minus 6 divided by 10 to the power of minus 3 minus 0.1 into 10 to the power of minus 3 is equal to 10 to the power of minus 2 divided by 0.9 into 10 to the power of minus 3. So here 10 to the power of minus 2 divided by 9 into 10 to the power of minus 4. So here 10 to the power of minus 2 plus 4 divided by 9, that is 10 square divided by 9 is equal to 100 by 9 ohms. This is the shunt resistance to be added to get the 1 milliamperes of current should be passes through it. So what is the option here? C is the option. Now the question number 23. An electron revolves in a circle of radius 0.4 angstrom units with a speed of 10 to the power of 6 meters per second in a hydrogen atom. The magnetic field produced at the center of the orbit due to the motion of electron in Tesla is how much? But given mu naught is equal to 4 pi into 10 to the power of minus 7 Henry per meter, and charge on electron is 1.6 into 10 to the power of minus 19 coulombs. So first of all, what are the given values we will write? So here radius of orbit r is equal to 0.4 angstrom units. So here 0.4 into 10 to the power of minus 10 meters, and afterwards they gave speed v is equal to 10 to the power of 6 meters per second, and charge on electron q is equal to 1.6 into 10 to the power of minus 19 coulombs, and also that permeability given mu naught is equal to 4 pi into 10 to the power of minus 7 Henry per meter. But here one condition we know: when electron revolves, contributes current. Electron revolving in a specific orbit, so that means how the current must be here? I is equal to q by t, but actually q divided by time means time period, that is 2 pi r by v. So it can be written as q into v divided by 2 pi r. So that means current I is equal to q 1.6 into 10 to the power of minus 19 into 10 to the power of 6 divided by 2 pi into radius, that is 0.4 into 10 to the power of minus 10. Here 1.6 into 10 to the power of minus 19 into 10 to the power of 6 divided by 2 into 0.4, 0.8 pi into 10 to the power of minus 10. Now 1.6 divided by 0.8 pi into 10 to the power of minus 19 plus 10 plus 6. So here 1.6 divided by 0.8 pi into 10 to the power of minus 3 amperes. This much amount of current we get from the electron revolves in the circuit. But which one we want to calculate here? Magnetic field produced at the center of the orbit. So that means magnetic field produced at the center of orbit. So B is equal to mu naught I by 2R. So mu naught means 4 pi into 10 to the power of minus 7 divided by 2 into 0.4 into 10 to the power of minus 10 into current 1.6 divided by 0.8 pi into 10 to the power of minus 3. So here 2 into 0 point, that is, I will take first of all 4 into 1.6, that is 6.4 pi divided by 0.8 into 0.8, 0.64 into 10 to the power of minus 7 minus 3 plus 10. Cancel. Pi cancel. 6.4 by 0.64 is nothing but 10 Tesla. So which option is correct here? Option C is correct. Now the question number 24. Two photons of energy is twice and thrice the work function of a metal are incident on the metal surface. Then the ratio of maximum velocities of photoelectrons emitted in the two cases respectively. So first of all, two photons of energy is twice and thrice the work function of metal. So first of all, we will take, let work function be phi. But here kinetic energy maximum is equal to incident minus work function, that is incident energy, that is E minus phi, that is kinetic energy maximum. So first of all I will take first E1 for first photon, that is 2 phi, and E2 is equal to 3 phi. But here K kinetic energy K1 maximum is equal to, that is E is nothing but E minus phi, that is 2 phi minus phi is equal to phi. K2 max is equal to 3 phi minus phi is equal to phi. But I want to find the ratio. K1 divided by K2 is equal to 2 phi. Phi divided by 2 phi, phi gets cancelled. So K1 divided by K2 is equal to 1 by 2. But here kinetic energy formula half m V1 square and half m V2 square is equal to 1 by 2. M cancel, 1 by 2 cancel. V1 by V2 whole square is equal to 1 by 2. But here V1 by V2 is equal to square root over 1 by 2. But here V1 is to V2 is equal to 1 is to root 2. So which option is correct here? Option D is correct. The question number 25. In Compton scattering process, the incident X radiation is scattered at an angle of 60 degrees. The wavelength of scattered radiation is 0.22 angstrom units. The wavelength of incident X radiation in angstrom units is how much? So first of all, Compton scattering process, the equation of Compton scattering process is lambda 2 minus lambda 1 is equal to h divided by m naught into c times 1 minus cos theta. But what are the given values? First of all I will take lambda 1, that is nothing but wavelength of incident radiation to be calculated. Lambda 2, that is nothing but wavelength of scattered radiation, that is given 0.22 angstrom units, whereas theta is given, that is 60 degrees. Then afterwards h by m naught into c is nothing but lambda naught. It is the Compton's wavelength of electron, that is given here lambda naught is equal to 2.43 into 10 to the power of minus 12 meters. It can be written as 0.024 into 10 to the power of minus 10 meters. This can be written as 0.024 angstrom units. Now substitute all the values in this equation. Lambda 2 0.22 minus lambda 1 is equal to 0.024 into 1 minus cos 60 degrees. 0.22 minus lambda 1 is equal to 0.24 minus 1 by 2. So here 0.22 minus lambda 1 is equal to 0.024 divided by 2. So here 0.22 minus lambda 1 is equal to 0.012. Here lambda 1 is equal to 0.22 minus 0.012. On simplification of this one, lambda 1 is equal to 0.208. So this is the value. Now which option is correct here? Option D is correct. Now the question number 26. If lambda naught is the de Broglie's wavelength for a proton accelerated through a potential difference of 100 volts, the de Broglie's wavelength for alpha particle accelerated through the same potential is how much? So first of all, here we will take proton and here alpha particle. Proton is nothing but one hydrogen 1, that is one proton is present, but alpha particle is nothing but 2 helium 4. But here mass of proton I will take MP, means mass of alpha particle, we will take this one as 4 times mass of proton, and charge of proton Qp means there is charge of alpha particle is equal to 2 times to the charge of proton. So this is the difference between proton and alpha particle. So first of all, what they gave here, that is de Broglie's wavelength of proton, lambda naught is equal to h divided by square root over 2 times mass of proton, charge of proton, and potential difference, that is I will take as V, but according to the proton they gave 100 volts is the potential difference. But for alpha particle also same potential difference they applied. Now here de Broglie's wavelength of alpha particle, that is lambda is equal to h divided by square root over 2 mass of alpha, charge of alpha, and potential. Here also potential is equal to 100 volts. So here now I will substitute is equal to h divided by square root over 2 times mass of alpha particle is nothing but 4 times to the mass of proton, and charge 2 times to the charge of proton, and potential difference. So here 4 2s are 8, so that I will write as 1 by root 8 h divided by square root over 2 times mass of proton, charge of proton, and potential difference. So here this completely taken as lambda naught divided by root 8. So lambda naught divided by root 8 can be written as 2 root 2, lambda naught by 2 root 2. Which option is correct here? C option is correct. Now the question number 27. Consider the following statements A and B. Identify the correct choice in the given answer. A. P and N, P and P, and N forces between nucleons are not equal and charge dependent. So P is proton, N is neutron. So proton and neutron, proton and proton, neutron and neutron, forces between these nucleons, that means proton, neutron, are called nucleons. The forces between the nucleons are not equal and charge dependent. So this is absolutely wrong. Why? Because the forces between nucleons must be equal, and that is charge independent. So that means this option is wrong. In nuclear reactor, the fission reaction will be in accelerating state if the value of neutron reproduction factor A greater than 1. So this is absolutely right. That means reproduction factor that is greater than 1 means nuclear reactor contains the fission reactions will be accelerated. So A is wrong and B is correct. So option C is correct. Now the question number 28. The masses of neutron, proton, and deuteron in AMU, that is atomic mass unit, are 1.00893, 1.00813, and 2.01473 respectively. The packing fraction of a deuteron in AMU, that means atomic mass unit, is how much? So first of all, what are the given values here? Mass of neutron is given, that is 1.00893 atomic mass unit, and here mass of proton is given 1.00813 atomic mass unit, and mass of deuteron is given, that is D, mass MD is equal to 2.01473 AMU. But to get the packing fraction is equal to mass defect by atomic number. So first of all, we will find the mass defect. Mass defect is nothing but delta M is equal to mass of neutron plus mass of proton minus mass of deuteron. So here 1.00893 plus 1.00813 minus 2.01473. So on simplification of that, 0.00233 AMU, atomic mass unit. But which one we want to calculate here? Packing fraction of the neutron, that is nothing but mass defect divided by atomic number. So mass defect means how much here? 0.00233 divided by atomic number of neutron is 2. So here I will take this one as 0.001165 and 11.65 into 10 to the power of minus 4 AMU, atomic mass unit. So which option is correct here? Option A is correct. Now the question number 29. In a transistor circuit, when the base current is increased by 50 microamperes, keeping the collector voltage fixed at 2 volts, the collector current increases by 1 milliampere. The current gain of the resistor is how much? So first of all, in a transistor circuit, first of all, increase in base current, that is IB is equal to 50 micro is nothing but 10 to the power of minus 6 amperes. Then afterwards here voltage is fixed, that is equal to 2 volts. The increase in current, increase of current in collector, that is delta IC is equal to 1 milliampere. That means 1 into 10 to the power of minus 3 amperes. But here which one we want to calculate here? Current gain we want to calculate. So that means current gain is equal to delta IC divided by delta IB. So delta IC 1 into 10 to the power of minus 3 divided by 50 into 10 to the power of minus 6. So that means 10 to the power of 3 divided by 50, 1, 2, 3. Here 10 to the power of 3, no? 10 that is 1000 divided by 50 is equal to 20. So here current gain is 20. So which option is correct here? Option A is correct. The question number 30. A common emitter transistor amplifier has a current gain is 50 if the load resistance is 4 kilo ohms and input resistance is 500 ohms. The voltage gain of the amplifier is how much? Options are given like that. First of all, this is common emitter transistor amplifier has a current gain is given. So that means here current gain is nothing but delta IC divided by delta IB is equal to 50, current gain. And afterwards load resistance is given, load resistance RL is equal to 4 kilo ohms, that is nothing but 4000 ohms, and input resistance also given, input resistance Ri is equal to 500 ohms. But here which one we want to calculate here? Voltage gain of amplifier is equal to output voltage divided by input voltage. So here output voltage is nothing but what is that? Delta IC into RL, that means resistance of load, and here input is nothing but base current into resistance of input. So we know this delta IC by delta B is nothing but current gain 50 into load we will take as 4000 and this is 500. So 2 zeros cancel, 5 tens are, so here 400 is the voltage. So which option is correct here? Option D is correct.